Okay, so I'm going to go through the practice test, how I would do the problem. So I would write amplitude, midline, B, P, CP off to the side, PS for the phase shift. And then we'll start. So we're going to do a cosine curve. So the amplitude is right here. So that's 3. The midline is right here. So that's 2. So I can go ahead and put those on. So I'm going to put a midline at 2. That means I will go up 3 then, the amplitude up 3. So this will be at 5. And I will go down 3, 1, 2, 3, -1. Sorry about that. So that's the max and min for this problem. Now, right in front of the x, there's an imaginary 1, if you will. It's 1x. And then remember, for sines and cosines and their partners, secant and cosecant, it's 2 pi divided by b, so that's just 2 pi. And then this one will be the period divided by 4, so that's pi over 2. And then if there's adding or subtracting inside the trig function, you want to solve for that. So you say x plus pi set it equal to 0, subtract pi to the other side, and you get x is negative pi. All right, so you get all that set up, and now we're going to go ahead and graph this thing. So I'm going to move over here to negative pi. I'll just say, okay, there's negative pi. And then you're going to add your CP number, which is at pi over 2. So if I add pi over 2, I'll be at negative pi over 2. And if I add pi over 2, I'll be at 0. And if I add pi over 2, I'll be at pi over 2. And add another pi over 2, I'm at pi. So again, you can just go to your calculator. It's -1 plus 1/2, math enter, enter, plus 1/2, math enter, enter, plus 1/2. And you'll keep getting your fractions, just put pi back on the top. Now, because it's a cosine curve, I go to the first critical point, and I'm going to put a dot at the maximum. But in this case, we have this flip. So we always report the amplitude as a positive, in this case, +3, and then we have to flip it. So we're not going to start at the maximum this time. I'm actually going to start at the minimum because we flip it top to bottom. Go to the next critical value. We'll be at the midline. This time we land on the y-axis. Make sure you don't, a lot of students stop here by accident. Make sure you go all the way to the bottom, hit the minimum. So if you need to, put some dotted lines across your max and mins, so all your dots hit the top and the bottom of your graph. But anyway, now I can just go through and draw my cosine curve. So now I'm going to do a tangent. So we can do the same amplitude, midline, B, P, CP, phase shift. All right. We don't really talk about amplitude for this because tangent and cotangent graphs go up and down forever. So amplitude is how far above the midline do you go, how far below the midline. Also, in this case, there is an imaginary, or there is a +0 at the end. So that would tell you the midline is 0. So you're going to be right on that x-axis for your midline. Then your b value, I have a 1 in front of the x again, but the rules change for the period and critical points of tangent and cotangent. So remember, it's pi over b. So that's just pi. And then it's period over 2. So those numbers are somewhat cut in half, if you think of it like that. And then phase shift, there is no phase shift because there's nothing being added or subtracted in the parentheses. So remember, a tangent goes 0, asymptote, 0, asymptote, 0. And so it wants to start at 0. And we're going to add this number. So we're just going to go to pi over 2. pi, 3 pi over 2, out to 2 pi. So it starts with a 0. The next one is an asymptote. Then it goes to a 0. Then it goes to an asymptote. These just alternate 0, asymptote, 0. And if you need to, you can type in tangent of 0 and it will tell you it's a dot. When you do cotangent, you do 1 over tangent and it's going to error out. So you know that one starts with the asymptote. And then the graph, tangents go up and to the right. So all these graphs go up and to the right, down and to the left. So that would be our tangent curve or graph. All right, so the last one is a cosecant. Amplitude is 2. We are going to take note that there will be another flip going on here. The midline is at 0. The B value is again 1. So we're not really changing in any of these practice problems the B value. The period then will be back to the normal rule, 2 pi over 1 or 2 pi, and period divided by 4. So that's pi over 2. And again, no phase shift, so none there. All right, so if I do the midline is at 0, that means I'm going to go up 2 and down 2 because of the amplitude. So the maximums and minimums will be at 2 and negative 2. And then because there's no phase shift, we're going to start at 0. And then you're going to add the CP. So you just add pi over 2. So pi over 2, pi, 3 pi over 2, all the way out to 2 pi. Now, when you do the reciprocals, secant and cosecant, make sure you go and you identify, okay, cosecant is partnered up with sine. Sine wants to start at the midline and go up. So normally it starts at the midline and goes up. But because of the flip, sine is going to start at the midline and go down. Then it will come back up all the way to the top and make sure you hit the midline there. Dotted line, this should be a ghost line, we said in class. It doesn't really show up on the graph. Wherever that line hits the midline, you are going to do vertical asymptotes. And then go back and look at your graph. Wherever you hit a minimum, touch the minimum, go down. Wherever there's a maximum, touch the maximum, and do U-shaped graphs. Those purple things, these U's, those are the actual cosecant graph in this case. All right. If a cosine graph has a maximum value at 6 and an amplitude at 5, so its maximum is at 6, well, the amplitude is 5. That's the space in between the next numbers. So if the maximum is at 6, amplitude is 5, that means I'm going to come down to 1 for the midline. And I would go down 5 more in this case. And I will be at negative 4. So maybe I'll sort that kind of looks like a line. So the midline's at 1. Go up 5 to 6. Go down 5 to negative 4. So the amplitude is the same distance between the three numbers. So what is the minimum value? It's at negative 4. All right. calculate the period of each, and explain how the periods relate to each other. Here, the b value is 1, so that means the period is pi over 1 because we're doing a tangent. Over here, the b is 1/2, so that means the period is pi divided by 1/2. Well, remember, dividing by a fraction, the answer is going to get bigger, or take pi times 2 over 1, and I get 2 pi. So you can see equation 1 has a period that is half of equation 2. When the b value is 1 or bigger, and then you do a b value that's smaller than 1, just compare the two. So however you think of it, the one on the left is half as much, or the one on the right is twice as much. All right, this will be the non-calc part of your test. So you would have your unit circle out. So when you do an arc sine is the inverse sine. When is sine -1? Well, that's at the bottom of your unit circle. We should say 90 degrees, negative 90 degrees, because arc sine only works from negative 90 to 0, 0 to 90. Yes, we're down at 270, but for domain and range, we need to be saying negative 90. Now, don't forget, we're actually doing the tangent. And what is the tangent at the bottom? Well, remember, it goes 0, -1. That's your cosine, that's your sine. Tangent is sine over cosine, and that's undefined. So undefined would be your answer. All right, go to 7 pi over 6. And if you look at 7 pi over 6 on the unit circle, that's -√3 over 2. We can go look at the unit circle. So 7 pi over 6, the cosine right there is -√3 over 2. Now they want the inverse sine of that. So arc sine means the same as inverse sine. So we need to find the two spots where sine is -√3 over 2. There's a -√3 over 2 here, and there's a -√3 over 2 here. Sine only works in these two quadrants. So go backwards from 0, and you're going to be at -60. Okay, if you go look at your unit circle again, when is cosine -1/2? Well, there'll be one here at 120 degrees. There's one down here at 240 degrees. But arc cosine only works up there, so the answer will be 120 degrees. Again, if you want to be in radian mode, you can. These problems, I recognize that 6 over 10 is not on the unit circle, so we want to make sure we know where to draw the triangle. So I'm doing an inverse cosine. That works in the top two quadrants. And cosine, this is a positive answer. Cosine is positive in those two quadrants. So I'm going to draw my triangle in quadrant 1, because that's where it lines up. Cosine is adjacent over hypotenuse. And if you do your Pythagorean theorem, 10 squared is 100, 6 squared is 36, and you do hypotenuse minus a leg, so that's 64. And I'm looking at the square root of 64 is 8, so my missing side is 8. Now, once you have done that, you're ready to answer when is or what is cosecant of that triangle. Now, cosecant is partnered up with sine, which is opposite over hypotenuse. So this is hypotenuse over opposite, which is 10 over 8, or 5/4 if you reduce. All right, another triangle. 3/5 is not on the unit circle. Where does sine work? These two quadrants. Where is sine positive? In the top two quadrants. So again, we're drawing our triangle in the first quadrant. Opposite 3, hypotenuse 5. That's a 3, 4, 5 triangle, or 25 minus 9 is 16, square root of 16 is 4. Just double check, do you need positives or negatives? But now I can do cotangent. What is the cotangent of my triangle? I guess theta would be there. Tangent is opposite over adjacent, so cotangent is adjacent over opposite. All right, now we're back on the unit circle stuff. Tangent, 3 pi over 4. That's the 45 in quadrant 2, so that's -1. And then it's saying when is cosine -1? That happens at 180 degrees. So I knew we were talking about the 45 here. Root 2 over 2, negative root 2 over 2. That's how I got -1 for tangent. And then when is cosine -1 is happening right there. So 180 degrees. Arc sine is 0. Well, arc sine is 0. Is talking about when is your sine value 0. And that happens over here, -1, 0. And it happens here is 1, 0. But arc sine doesn't work over there. It only works here. And so now we have to decide, is it 0 degrees or 360 degrees? But arc sine only works from -90 to 0 to 90. So technically that is not, even though it's the right location, we want to say it is 0 degrees. But then don't forget you have this cosine. So when is what is the cosine of 0 degrees? Well, you just go to your ordered pair and it's a 1. All right, almost done. Arctangent, -1, that's going to happen here, and it's going to happen here. So 135 degrees, 135 degrees or 315 degrees. Well, arctangent only works on this side of the unit circle. So this is the correct location, but we want to make sure, just like tangent, we have to go from 0, we have to go backwards 45 degrees. So my answer, the better answer, is -45 degrees. And then the last one, when is arctangent √3? We want to remember tangent of 30 is √3 over 3, 45 is 1, 60 is √3. So arctangent is √3 is happening at 60-degree angles. So it's at 60 or it's at 240. Well, arctangent, remember, only works on this side. So this is going to be 60 degrees. And then they say, don't forget we have to do the cosine. What is the cosine of 60 degrees? If you go to the unit circle, or maybe you know it, cosine of 60 is 1/2.